Welcome to CO556 Network Systems. This is week 6. This week we're looking at Cisco Chapter 9, which is on first hop redundancy protocol concepts. The objective this week is to explain what first hop redundancy protocol concepts are all about. We'll explain how first hop redundancy protocols provide default gateway services in a redundant network. We'll explain the purpose and operation of first hop redundancy protocols, and we explain how HSRP will operate. First hop redundancy protocols. Default gateway limitations. End devices are typically configured with a single default gateway IPv4 address. If the default gateway router interface fails, local area network hosts lose outside local area network connectivity. This occurs even if a redundant router or layer 3 switch that could serve as a default gateway exists. First hop redundancy protocols, FHRPs, are mechanisms that provide alternate default gateways in switched networks where two or more routers are connected to the same VLANs. Router redundancy. One way to prevent a single point of failure at the default gateway is to implement a virtual router. To implement this type of router redundancy, multiple routers are configured to work together to present the illusion of a single router to the hosts on the LAN. By sharing an IP address and a MAC address, two or more routers can act as a single virtual router. The IPv4 address of the virtual router is configured as the default gateway for the workstations on a specific IPv4 segment. When frames are sent from host devices to the default gateway, the hosts use ARP to discover or to resolve the MAC addresses that is associated with the IPv4 address of the default gateway. The ARP resolution returns the MAC address of the virtual router. Frames that are sent to the MAC address of the virtual router can then be physically processed by the concurrently active router within the virtual router group. A protocol is used to identify two or more routers as the devices that are responsible for processing frames that are sent to the MAC or IP address of a single virtual router. Host devices send traffic to the other address of the virtual router. The physical router that forwards this traffic is transparent to the host devices. A redundancy protocol provides the mechanism for determining which router should take an active role in forwarding traffic. It also determines when the forwarding role must be taken over by a standby router. The transition from one forwarding router to the other is transparent to the end devices. The ability of a network to dynamically recover from the failure of a device acting as a default gateway is known as first hop redundancy. Steps for router failover. When the active router fails, the redundancy protocol transitions the standby router to the new active router role, as shown in this figure here. These are the steps that take place when the active router fails. The standby router stops seeing hello messages from the forwarding router. The standby router assumes the role of the forwarding router. Because the new forwarding router assumes both the IPv4 and MAC addresses of the virtual router, the host devices see no disruption in service. First hop redundancy protocol options. There are various different flavors of first hop redundancy protocols. The first, Hot Standby Router Protocol, HSRP. HSRP is a Cisco proprietary FHRP that is designed to allow for transparent failover of a first hop IPv4 device. HSRP is used in a group of routers for selecting an active device and a standby device. The active device is a device that is used for routing packets. The standby device is the device that takes over when the active device fails or when preset conditions are met. HSRP for IPv6. This is also a Cisco proprietary FHRP that provides the same functionality of HSRP but in an IPv6 environment. An HSRP IPv6 group has a virtual MAC address derived from the HSRP group number and the virtual IPv6 link local address derived from the HRVP virtual MAC address. Periodic router advertisements are sent to the HSRP virtual IPv6 link local address when the HSRP group is active. When the group becomes inactive, these router advertisements stop after a final router advertisement is sent. Virtual Router Redundancy Protocol version 2, VRRP version 2. This is a non-proprietary election protocol that dynamically assigns responsibility for one or more virtual routers to the VRRP routers on an IPv4 LAN. This allows several routers on a multi-access link to use the same virtual IPv4 address. In a VRRP configuration, one router is elected as the virtual router master, with the other routers acting as backups in the case the virtual master router fails. VRRP version 3. This provides the capability to support IP version 4 and IP version 6 addresses. VRRP version 3 works in multi-vendor environments and is more scalable than VRRP version 2. Gateway Load Balancing Protocol, GLPBP. This is a Cisco proprietary FHRP that protects data traffic from a failed route or circuit, like HSRP and VRRP, while also allowing load balancing, also called load sharing, between a group of redundant routers. GLBP for IP version 6. This is also a Cisco proprietary FHRP that provides the same functionality of GLBP, but in an IP version 6 environment. GLBP for IP version 6 provides automatic router backup for IP version 6 hosts configured with a single default gateway on a LAN. Multiple first hop routers on the LAN combine to offer a single virtual first hop IP version 6 router while sharing the IPv6 packet forwarding load. ICMP Router Discovery Protocol, IRDP. Specified in RFC 1256, IRDP is a legacy FHRP solution. IRDP allows IP version 4 hosts to locate routers that provide IP version 6 connectivity to other non-local IP networks. HSRP, Hot Standby Redundancy Protocol. Overview. Cisco provides HSRP and HSRP for IP version 6 as a way to avoid losing outside network access if your default router fails. HSRP is a Cisco proprietary FHRP that is designed to allow for transparent failover of a first hop IP device. Hot Standby Routing Protocol, Redundancy Protocol, ensures high network availability by providing first hop routing redundancy for IP hosts on networks configured with an IP default gateway address. HSRP is used in a group of routers for selecting an active device and a standby device. In a group of device interfaces, the active device is the device that is used for routing packets. The standby device is the device that takes over when the active device fails or when preset conditions are met. The function of the HSRP standby router is to monitor the operational status of the HSRP group and to quickly assume packet forwarding responsibility if the active router fails. HSRP priority and preemption. The role of the active and standby routers is determined during the HSRP election process. By default, the router with the numerically highest IP version 4 address is elected as the active router. However, it is always better to control how your network will operate under normal conditions rather than leaving it to chance. HSRP priority can be used to determine the active router. The router with the highest HSRP priority will become the active router. By default, the HSRP priority is set to 100. If the priorities are equal, the router with the numerically highest IP version 4 address is elected as the active router. To configure a router to be the active router, use the standby priority interface command. The range of the HSRP priority is 0 to 255. By default, after a router becomes the active router, it will remain the active router even if another router comes online with the highest HSRP priority. To force a new HSRP election process to take place when a higher priority router comes online, preemption must be enabled using the standby preempt interface command. Preemption is the ability of the HSRP router to trigger the re-election process. With preemption enabled, a router that becomes online with a high HSRP priority will assume the role of the active router. Preemption only allows a router to become the active router if it has the higher priority. A router enabled for preemption with the equal priority but a higher IP version 4 address will not preempt an active router. Refer to the topology that we see in this figure. With preemption disabled, the router that boots up first will become the active router if there are no other routers online during the election process. HSRP states and times. The initial state of an HSRP. This state is entered through a configuration change or when an interface first becomes available. The learn state. The router has not determined the virtual IP address and has not yet seen a hello message from the active router. In this state, the router waits to hear from the active router. The listen state. The router knows the virtual IP address, but the router is neither the active router nor the standby router. It listens for hello messages from those routers. Speak. The router sends periodic hello messages and actively participates in the election of the active and/or standby router. Standby. The router is a candidate to become the next active router and sends periodic hello messages. The active and standby HSRP routers send hello packets to the HSRP group multicast address every 3 seconds by default. The standby router will become active if it does not receive a hello message from the active router after 10 seconds. You can lower these timer settings to speed up the failover preemption. However, to avoid increased CPU usage and unnecessary standby state changes, do not set the hello timer below 1 second or the hold timer below 4 seconds. FHRP provides alternate default gateways in switched networks where 2 or more routers are connected on the same VLANs. One way to prevent a single point of failure at the default gateway is to implement a virtual router. With a virtual router, multiple routers are configured to work together to present the illusion of a single router to the hosts on the LAN. When the active router fails, the redundancy protocol transitions the standby router to the new active router role. These are the steps that take place when the active router fails. The standby router stops seeing hello messages from the forwarding router. Standby router assumes the role of the forwarding router. Because the new forwarding router assumes both the IP version 4 and MAC addresses of the virtual router, the host devices see no disruption in service. The HSRP used in the production environment largely depends on the equipment and needs of the network. These are the options available for HSRPs. HSRP and HSRP for IP version 6. VRRP version 2 and version 3. GLBP and GLPBB for IP version 6. And finally, IRDP, which is legacy. HSRP is a Cisco proprietary FHRP designed to allow for transparent failover of the first hop IP device. Hot standby routing redundancy protocol is used in a group of routers for selecting an active device and a standby device. In a group of device interfaces, the active device is the device that is used for routing packets. The standby device is a device that takes over when the active device fails, or when preset conditions are met. The function of the HSRP standby router is to monitor the operational status of the HSRP group and to quickly assume packet forwarding responsibility if the active router fails. The router with the highest HSRP priority will become the active router. Preemption is the ability of an HSRP router to trigger the re-election process. With preemption enabled, a router that comes online with a higher HSRP priority will assume the role of the active router. HSRP states include initial, learn, listen, speak, and standby. We have a little packet tracer exercise for hot standby redundancy protocol configuration guides. In the packet tracer activity, you learn how to configure hot standby router protocol to provide redundant default gateway services to hosts on LANs. After configuring HSRP, you will test the configuration to verify that hosts are able to use the redundant default gateway if the current gateway devices become unavailable. You get to configure an HSRP active router, configure an HSRP standby router, and verify HSRP operation.